Okay, the law of cosines, similar to the law of sines in that it helps you to find the same parts of a triangle. The formula itself, however, looks very, very different than that of the law of sines. What's important to note about the law of cosines is the fact that you use it when you're in a situation where you know three sides of a triangle, or you have two sides and they include an angle, and you're trying to find that third side. Side, side, side would be if you had all three sides and you were trying to find one of the angles of the triangle. So those would be the situations that you would use the law of cosines. So here it is in three different forms. You do not need to memorize all three of these forms. It's all the same thing. I'm going to dissect it for you in a second. It's just a matter of understanding what's going on in the formula itself. And if you can remember this part of it, I think this will be helpful to you. The side and the cosine of the angle opposite that side are always the bookends of the formula. So if you look at side A, and then on the other end of the formula is cosine A. And the second one, we've got side B, and on the other end of the formula is cosine B, and same with this third one. Side C on the other end of the formula is cosine C. So I just call them the bookends because that kind of keeps everything together, and it helps to remember why you're using the particular formula. Okay, let's take a look at the picture. Remember, the side opposite the angle is the same letter as the angle, just lowercase. So the lowercase letters are referring to the sides. And it just follows a pattern. So the square of any side of a triangle is equal to the sum of the squares of the other two sides minus 2 times the product of the other two sides times the cosine of the angle between the sides. Okay, that's what the formula is saying. And I know that's a lot of words. It's just a matter of getting used to it. Side A squared is, so side A squared is equal to side B squared plus C squared minus 2 times B times C times the cosine of the angle between them. And that's what happens with every single one of these. So you see these letters changing, but they all are doing the same thing. So I just wrote it out 3 different ways so you can see that it works for any side and any angle. You can use it any part of that triangle as long as you're you know what you're looking for. Okay. Also, the letters are arbitrary. I could have used JKL. I could have used XYZ. The letters don't matter. It's just understanding how the formula works. So we'll go through a couple of examples so you can see what's going on. Example 1, triangle ABC. If A equals 4, C equals 6, and cosine of B is 1 over 16, find B. First thing you always want to do is draw yourself a picture. It does not have to be to scale. It's just honestly for visualization purposes. So this is triangle ABC. Side A, which is opposite angle A, is 4. Side C, opposite angle C, is 6. And I know that the cosine of that angle is 1/16. So I have side, angle, side, and they're asking me to find the other side. Okay, so I've got my bookends, B squared, and I've got cosine of B. So my formula says this. B squared is the square of the other two sides minus 2 times the product of the other two sides times the cosine of the angle. So from here I can just fill in my missing parts. I've got B squared is equal to 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of B, which is 1 over 16. And if we do that out, and we can do that in our calculator just as one big calculation. So I've got 4 squared is 16, 6 squared is 36, minus 2 times 4 times 6 times 1/16. And that gives me b squared, which is 49. And that means that b is 7. And that's my missing side. That's the value that I was looking for. Okay, so very straightforward formula. Okay, let's try another example. In triangle LMN, again, I'm going to draw myself a picture. Again, this doesn't have to be to scale. It's just for illustration purposes. LMN. Side L is 12, side N is 16, and side N is 9. This is find angle N to the nearest degree. Okay, so since I'm looking for this angle, this is the side opposite it, those are going to be the bookends of my formula. So I've got 9 squared. And on the other end, I have cosine of n.
It's magic, okay.
So then the rest of my formula is the square of the other two sides added together minus 2 times the product of the other two sides times the cosine of that angle. Okay, so that would give me 81 is equal to 16 squared, which is, and I don't know why I always draw a blank on that, 256 plus 144. Okay, so 16 squared plus 12 squared would be 400 minus 2 times 16 times 12. 2 times 16 times 12. That gives us 384 times the cosine of n. Now be very careful. A common mistake that people make is that they want to do 400 minus 384. You can't do that because that 384 is attached to the cosine of n. Okay, so what I can do though is I can move that 400 over to the other side. And that would give me 81 minus 400. Gives me negative 319 is equal to negative 384 cosine of n. Divide both sides by negative 384. So we get cosine of n is equal to 319 over 384. Right? A negative divided by a negative is a positive. So in our calculator, if I do 319 divided by 384, and then if I do second cosine, because I'm finding now the angle, so I have to do inverse cosine. Second cosine of my answer. So second and then the negative symbol will pull up your previous answer. Enter. And we get n is 33.8, so to the nearest degree, n is 34 degrees. Okay. So those are two different ways you can use the law of cosines formula. Another way that you could use it is if you're asked to solve the triangle. And solving the triangle simply means that you're finding all of the missing parts. So any missing sides and any missing angles. So in triangle RST, I've got side R is 11, side S is 12, I've got angle T is 120. Now clearly I didn't draw this to scale. Again, I'm just drawing it for illustration purposes so I can see what parts I'm missing. Okay, so I have two sides and the included angle. I need to find that missing side. So I'm going to go ahead and use law of cosines. Remember, my side and my angle opposite it are the bookends of my formula. So I've got cosine of 120. And that's going to equal 12 squared plus 11 squared minus 2 times 12 times 11. And we can easily just do that in our calculator. So I've got 12 squared plus 11 squared minus 2 times 12 times 11 cosine 120,
pretty big. So let's take a look back at this.
and that gives me 397.
So it's going to be pretty warm.
So t is going to equal the square root of 397. Okay, that's the exact value. I'll use the exact value when I'm finding the missing angle, but the to represent the side, because it says to round side to the nearest tenth, I'll just take the square root of that.
You also have a lot of warm air coming in from the Atlantic.
So to the nearest tenth, that looks like t is going to be 19.9. Okay. Now, to find the missing angles, I can now choose either angle I want, because I'm going to now use the law of sines, because I'm trying to find a missing angle, and I have another angle and side. Okay, so I can go ahead and use the law of sines here. So I'm going to say the sine of r over 11 is going to equal the sine of 120 over square root of 397, because I want to use the exact value. I don't want to use the rounded value to then re-round another side. So if I cross multiply, actually I don't even need to cross multiply. I can just multiply both sides by 11. So that'll get rid of the 11 here. It gives me the sine of r is equal to 11 sine of 120 over square root 397. I can do that in my calculator. I can do 11 sine 120 close parentheses divided by square root of 397. And that'll give you the sine ratio if I just do second sine, second answer, and that'll give me angle r. And angle r is going to be rounded to the nearest degree, is going to be 29 degrees. So angle r is going to be 29 degrees. And then I can easily find s simply by the fact that the sum of the angles of a triangle adds up to 180. So 120 plus 29 would be 149. So from subtract that from 180 and you get 31 degrees. 31. And that's how you would solve a triangle. Okay, hopefully that helps. I've got another video with some application problems that's coming up next. Thanks.